Open up your workbook to page 49, and we're going to begin working on scientific notation. We're looking at the problem up at the top that asks us how many bytes can be stored on a 4.7 gigabyte DVD. We're going to go ahead and fill in our chart below working with scientific notation. We're taking numbers written in scientific notation and we're going to write them in standard form. So 4.7 times 10 squared is going to be 470. 4.7 times 10 cubed is 4,700. And 4.7 times 10 to the fourth is 47,000. Notice that each one of those numbers increased. We started with 4 and 7/10, and when we multiplied it by a power of 10, it went up to either 470, 4,700, or 47,000. Now we're going to take a look at the other column, and this time our exponents are negative. So now our numbers are going to decrease. So 4.7 times 10 to the negative 2 is decimal 047. 4.7 times 10 to the negative 3 is decimal 0047. And 4.7 times 10 to the negative 4 would be multiplying times 1 over 10,000. And so our answer is going to be decimal 00047. So what happens when an exponent is positive? Well, the positive exponent tells us how many places the decimal moves to the right. And when it's negative, it tells us how many places the decimal moves to the left. There should be many. Alright, scientific notation. When we take a number that is in standard form and put it into scientific notation, the decimal is going to be a decimal that has one digit in front of the decimal. So it's always going to be a number that's going to be between 1 and 999. It's not going to be less than 1, and it's not going to be more than 999. So we always want to check that when we're changing a number from standard form to scientific notation. Alright, so let's take a look. Right now we're going to be working with changing scientific notation. Open up your workbook to page 49. We're looking at a problem that is asking us how many bytes can be stored on a 4.7 gigabyte DVD. So we're going to go ahead and fill in the charts and take a look at how we would figure that out, knowing that 1 gigabyte is equal to 10 to the 9th bytes. So what we're going to do is we're going to take some numbers that are written in scientific notation and we're going to write them in standard form. 4.7 times 10 squared is going to be 470. 4.7 times 10 cubed is going to be 4,700. 4.7 times 10 to the fourth is 47,000. Notice that when we multiply by a positive exponent, the number gets bigger. When we multiply by a negative exponent, the number gets smaller. So 4.7 times 10 to the negative 2 is decimal 047. 4.7 times 10 to the negative 3 is decimal 0047. 10.7 times 10 to the negative 4 is the same as 4.7 times 1 over 10,000, which is going to be decimal 00047. When we look at the exponent tells us two things. It tells us how many places to move the decimal and which direction. If it's a positive exponent, then the exponent tells us how many places the decimal moves to the right. If it's a negative exponent, then it tells us how many places the decimal moves to the left. When we're looking at a number can be in standard form, as this number is right here, 425 million, or it can be written in scientific notation, where the first number is a decimal, and it is between 1 and 999. It's not going to be less than 1, and it's not going to be more than 999. So now let's practice. We're going to take 7.42, and we're going to need to move that decimal 5 places to the right because 5 is positive. So it's going to be 1, 2, 3, 4, 5. And we're going to go ahead and fill in our zeros. So our answer is going to be 742, 0, 0, 0. Be sure and put your comma in. The next one's going to be 6.1. And now we have a negative exponent, so we're going to go 2 places to the left. 1, 2, and we're going to fill in with our 0. So it's going to be decimal 0, 6, 1. The next one is going to be 3.714. Our exponent is positive 2, so that tells us we're going 2 places to the right. So it's going to be 371 decimal 4. Now let's look at how we do it when we have a number in standard form and we have to put it into scientific notation. Well, the first thing that we're going to do is we're going to write our number, and we have to put our decimal in. Now when we put our decimal in, we only want 1 digit in front of the decimal, and that digit has to be any digit but 0. So we've put our number in, and we put our decimal in, and now what we're going to do is move our decimal so that our number matches the number that we started with. So we started with 3,725,000, and right now we have a number that's much smaller because it's just 3 and then a decimal number behind it. So what we're going to do is we're going to move that decimal, and we're going to count. So we're going to count 1, 2, 3, 4, 5, 6. Notice that I moved to the right. So my answer is going to be 3.725 times 10 to the 6th. Alright, let's take a look at the next one. You write your number first, 00316, and you put the decimal in where it belongs. So there's 1 digit, any digit, as long as it's not 0, and it has to be in front of the decimal. So we know that our answer is going to be 3.16, and now we're going to move 1, 2, 3, 4 places to the right, which gives us 10 to the negative 4. Alright, let's practice some more. So we're going to go ahead and write our number 1414000, and we're going to go ahead and put our decimal in. So we know our decimal is 1.414, and now we need to figure out what our exponent's going to be. So now we're going to count 1, 2, 3, 4, 5, 6, 7, and we want 7 to the right. Alright, let's write our number again, 0076, and we have to put our decimal in. So we know our decimal is going to be 8.76 times 10 to the something. Now, we have to move the decimal so that our number matches the number that we started with. We're going to go 1, 2, 3 decimals places to the left. So it's going to be 10 to the negative 3. Now we have 114. We're going to put our decimal in. Again, we want to go back and match the number we started with. So we're going to do 1 place to the left, so it's going to be 10 to the negative 1. if we are looking at numbers and we're having to compare numbers, you're going to notice that we compare numbers that have the same exponents. So here we're trying to figure out the order that the countries would be in from least to greatest when we're looking at dollars spent by visitors. So what we're going to do is we're going to look at Canada and United Kingdom first because they both have a 10 to the 7th power. Notice that because the exponent is the same, we just look at the decimals. So United Kingdom is larger. Now we're going to compare Mexico and India. Mexico and India both have 10 to the 6th as their exponent. So now all we're going to do is look at the decimals, and we're going to notice that Mexico is larger. And now we can put them in order. So United Kingdom, from greatest to least, it would be United Kingdom, and then it would be Canada, and then we have Mexico, and then we have India. All right, so now let's look at this last question. In an ocean, the seafloor moved 475 kilometers over 65 million years. Is it more important to report this rate as 7.31 times 10 to the negative 5 kilometers per year or 7.31 centimeters per year? If you guess 7.31 centimeters per year, you're correct. And the reason is that it moves such a small distance that we want to use the smallest measurement possible.